All right, so we're moving into section 2.6 here, which is formulas. Actually, I think technically the name of the section is literal equations, but um, most literal equations are actually formulas. So that's what formulas are, right? So formulas are really just equations, but they're specifically equations that express relationships between two or more variables. Okay, so a very common formula is F equals 9/5 C plus 32. And what that formula does is it allows us to convert from degrees Celsius to degrees Fahrenheit. So generally there's two different things we can do with formulas. The first thing is just to evaluate them for specific values of a variable. So in the case of this one, F equals 9/5 C plus 32, we can evaluate F when C equals 5. So all that really means is that we're plugging in 5 for C and finding out what F is. So we're just going to write F equals 9/5, and now where we see the C, we're going to put a 5 times 5 plus 32. And if we remember here now what happens, our 5's will cancel, and we'll just have F equals 9 plus 32. So in this case, F equals 41. So when C equals 5, F equals 41. So what that generally means is it just means that 5 degrees Celsius is equivalent to 41 degrees Fahrenheit. All right. And we can do this with any value of C we want. Okay. So all it means is to substitute a value for C and find F. So let's say we want to do another one. All right. Well, evaluate F if C equals 35. Well, if C is 35, we're going to do the same thing we did above, rewrite the formula. But now where we see the C, we're going to replace it with 35. And similarly to what happened before, 35 over 5, 5 goes into itself once, and 5 goes into 35 7 times. So this would be 9 times 7, which is going to be 63 plus 32. And again, notice how we're not changing the left side at all here. The left side is just F equals, because that's what we're trying to solve for. So it's already isolated, and that's the key here. So 63 plus 32 then is just 95, and now we're finished. So F equals 95. So that's really just basically like evaluating an expression. I mean, yes, it's an equation because we do have a left side, but the left side is already isolated, right? It was just F equals. So all we had to do was simplify the right side, and we end up with 95. So what this means is that 35 degrees Celsius is equivalent to 95 degrees Fahrenheit. All right, so that's the first thing that we'll do with formulas, right? Very straightforward. We're just evaluating for one value of the variable given the other one. So the second thing that we can do with formulas is solve them for one of their variables in terms of the others. So in that above example that we had given, right, F equals 9/5 C plus 32, that formula was solved for solved for F in terms of C, right? So why do we say that it was solved for F in terms of C? Because F appeared alone on one side of the equation and the other side did not contain F at all, right? We had F equals 9/5 C plus 32. So F appeared alone on the left side and the other side did not contain F. It only contained C. So if we want to do the reverse now and solve it for C in terms of F, we're going to make it so that C appears alone on one side of the equation and the other side will contain only F. It will not contain C, right? So we're going to get it in a C equals form, right? So what we want, our goal is to get it to look like C equals something, that doesn't have C in it, right? That only has F. So that's our goal. So how are we going to do that? We're going to do that basically by treating the other variables like they're constants, right? So we're going to treat the F as if it was just a number. So what we're going to do is we're going to write F equals 9/5 C plus 32. So how would we solve this thing for C? Right? Well, we would treat the C like it's the thing that we want to isolate. Okay? So we want to isolate the C. So how do we get this C by itself? All right, well, we have to get rid of the 32 and we have to get rid of the 9/5. So the way we're going to get rid of the 32, since it's being added, is to subtract it. So now on the right side it's gone, cancels out. And on the left side we have F minus 32. Well, what is F minus 32? Well, it's just F minus 32 because those two terms are not like terms, so they can't be combined. So we have F minus 32 equals 9/5 C. So now what would we do? Well, now we got to get rid of the 9/5. So generally the way we got rid of a fraction coefficient is we multiply by the reciprocal. So the reciprocal of 9/5 is going to be 5/9. So we're going to multiply the right side by 5/9 and the left side by 5/9. And now we're done, right? The 9/5 and the 5/9 just cancels on the right side, so we just have C on the right side, and on the left side, well, we can just leave it in that form, really. We can just leave it as 5/9 times F minus 32 equals C. Now, could we write it in a different form if you wanted to? Yeah, we could take the F minus 32 and put it up in the numerator. And this is optional. You don't have to do this, but you could write it as 5 times parenthesis F minus 32 over 9 equals C. So that's another way to write it. Okay? And the advantage of doing this now is now it makes it easy to evaluate C for any value of F, which is the opposite of what we did prior, right? Before we were given a C value and we had to find F. Now we would be able to use this new formula to find C if we're given F. So let's just suppose, okay, well, maybe what is C when F equals 41, right? So evaluate C when F is 41. So all we'd have to do then is replace the F with 41 and find C. So what we could do is we could just switch the sides here. So write C equals 5, replace F with 41, and now just use order of operations. Well, 41 minus 32 is 9, so this is just 5 times 9 over 9. And then what would happen is the 9's would cancel, and we just have C equals 5. So we just evaluated C when we knew what F was, right? When F was 41, C was 5. So those are the two things that you can do with the formulas, right? You can either evaluate or solve for one variable in terms of the others.